Chemical equation. Students, a chemical equation represents a chemical reaction with the help of symbols and formula. A chemical equation is symbolic representation of an actual change. A chemical equation representing in words is called word equation. While writing such equations, more time, space, and effort is consumed. Therefore, symbolic equations are used for writing chemical reactions in chemistry, and this is called language of chemistry. In a chemical equation, the chemicals which take part in reactions are called reactants, and the substances which are formed due to a certain condition present are called products. In the representation of chemical equation, the reactants are written on the left-hand side of the arrowhead and the products on the right-hand side. The arrowhead shows the direction in which the reaction is going. The sign shows irreversible reaction, whereas this symbol shows reversible reaction, and this sign shows equality. The gases are shown by the symbol and precipitates by this symbol. A solid is given by the symbol S, liquid by L, and gas by G in some cases. Essentials of chemical equations. Students, a chemical equation has three essential characteristics. They are: A. It should represent an actual chemical change. B. It should be balanced. C. It should be molecular. An equation which indicates the evolution or absorption of heat in the reaction is called a thermochemical equation. In an endothermic reaction, minus sign is used to indicate the absorption of heat, while in an exothermic reaction, plus sign is employed to show its evolution. For example, nitrogen and oxygen combine to form nitrogen oxide. That is, N2 plus O2 is equal to 2NO minus 43,000 calories. Similarly, carbon and oxygen combine to form carbon dioxide with the liberation of heat as equal to 94,300 calories. That is, C plus O2 equals CO2 plus 94,300 calories. The factors of chemical reactions. Students, there are different factors that influence chemical reactions. Some of the most important factors are listed as follows. A. Heat, electricity, and light energy. These play a role in the chemical reaction. Some substances break down due to heat. Calcium carbonate can be decomposed into calcium oxide and carbon dioxide by applying heat. Some substances react in the presence of light. Silver bromide reacts in the presence of sunlight and gives silver and bromine. B. By contact. Students, some substances when brought in contact react vigorously and give a compound. For example, iodine and phosphorus react immediately as soon as they come in contact. Sodium and chlorine also react and give sodium chloride. That is, 2Na plus Cl2 gives 2NaCl. C. By dissolving. Some substances in liquid form or soluble form react readily, whereas in solid form they do not react. For example, sodium chloride and silver nitrate react in liquid form, like NaCl plus AgNO3 reacts to form NaNO3 plus AgCl. D. By pressure. Students, some substances like mixture of potassium chloride and sulfur explodes due to pressure. E. By catalyst. Some substances react slowly when there is absence of catalyst, but they react much faster at lower temperature due to the presence of catalyst. For example, 2KClO3 decomposes at 360 degrees centigrade into 2 KCl plus 3O2. This is a reaction at high temperature, but the same potassium dichlorate decomposes into 2 KCl plus 3O2 in the presence of a catalyst manganese dioxide at a lower temperature of 240 degrees centigrade. That is, reaction at low temperature due to the presence of manganese dioxide. Catalyst. A catalyst is a chemical substance that does not take part in a chemical reaction, but its presence generally enhances the chemical reaction. Some catalysts help to retard the chemical reaction. Such catalysts are known as negative catalysts. Manganese dioxide is a positive catalyst since it increases the rate of chemical reaction.